Namaskar, my dear friends. Let us talk about how we can convert a current source to a voltage source. So there are a lot of applications where you would have seen that there is a current source which is varying like this. Let us say 0 milliamperes to let us say 20 milliamperes. So this is my current source, and corresponding to this we will be trying to find out what is my voltage that is there. So let us say we want to convert it to or scale it up to 0 to 2 volt. Understood? So from current to voltage output, how we can get, we can simulate that amplifier circuit in LTSpice and we'll try to understand. So if you see a circuit that we had designed, you can see we have LTC2063. So we have a current source here which is going to go ahead with, like you can see I1, that is green color, it is going up to 20 milliamps, right? And you can see V output, that is going up to 2 volt, the red color one, right? So going like this and then coming down. So we will construct this circuit in LTSpice and we'll try to show it to you like how it can be varied very nicely current to voltage converter. This is very important circuit that is there in electronics design circuits and everything. So let's open LTSpice. We'll open a new circuit. So press new schematic. Now what do we need here? We need to place op amps and all those other components, right? So for that, either you can press P to place the components, or you can go to this component to find the components, right? So let us find out an op amp that we want to use. LTC2063. You can see we have LTC2063, 2064, 2065. So 2064 is double op amp, 2065 is quad op amp. That is 4 op amps are there in that. So 2063 we will take, which is having single op amp. Okay. Now we'll place it. So this is done. Now what do we need? We need resistors for the amplification purpose, right? So to design an amplifier, we can have a inverting amplifier kind of thing. Let's say R1, R2. We may need a load resistor, so I can put it a series resistor here, and then we'll be needing kind of a reference resistor which will convert my input current to a voltage, right? So this is how resistors we have placed. Now we may need capacitors. So let us say one output capacitors we may need to drive the output load, and we may need one capacitor for supply voltage as well. So I'll just keep supply outside so that we can put it little easier. So supply output outside. Now we need voltage source. So press V to get a voltage source. I am going to put voltage source for supply purpose. And what else we need? We need to have, this is shutdown signal. So shutdown signal also will need one supply. So I'll put two voltage sources. All right. Then we need current sources. So press P and find out current. So this is just write down CU. So it will come current. Just place it. So if you want to rotate it, you can press Ctrl R. So it will rotate. All right, so what is there that we have is, we have a current source. That current is going to enter into my node, I mean inverting and non-inverting node of the op amp, and then this will get amplified as a voltage to give you the voltage output, right? So to quickly complete the circuit, what do we need? We need to wire it up, right? So we'll place, like grounds as well. Wherever we need ground, we can place them, right? So grounds are placed. Now let us put it here as well. Okay, done. So now what we are going to do is, we are going to quickly wire it up. So you already know how to wire the circuit quickly. So press W to get the wire, and then you can quickly wire it up. Okay. So one by one you can wire this up. Moving to next, we are wiring the negative supply. This positive supply, what I will do is, I'll press N to get a plus, let's say V. So it will be plus V. I'll put it plus V here also. Okay. So that, it can be named the same thing. Understood? Now this capacitor I can put it here, and this capacitor is done. Now the last part of the circuit, we can very easily connect it or wire it up like this. So now you can see very nicely our circuit is wired up. Like we have positive supply voltage that is going to give a supply to the op amp, right? Now this inverting input, it will get connected at this particular node so that it will give you the proper required amount of gain, right? Now what do we need? We need to define the values of each of the components. So what do we do is we can give a supply voltage of, let us say, 3.3 volt. So 3.3 volt we can give. Similar to that, here shutdown signal voltage also we can give 3.3. Let us say this resistor will give right now 1 ohm, okay? And the current source we want to vary it, right? So we want to vary a triangular voltage. In that case, what we can do? We can go to advanced and we can find out a source which is called as PWL source, that is piecewise linear source, okay? If you press this, you have timestamps and you have a requirement of a voltage that you need. So let us start with 0 time and we'll keep 0 voltage, okay? Or 0 amount of current, right? Now let us say at 1 second of time we can make it 20 milliampere of current. That's the reason we are putting this. Then we can 2 second, we can put it again 0. So it will reach from 0 to 1 second, it will reach from 0 milliamperes to 20 milliampere. And then from 1 second to 2 second, it will reach from 20 milliamperes to 0 milliampere, right? Then press OK. So this is done. Now talking about the gain and all, so let's see. So coming to the circuit, we can see that we have V output as non-inverting amplifier 1 plus R2 by R1 into V input. So we can have like 1000 kilo ohm by 10 kilo ohm, that is 1 mega ohm by 10 kilo ohm. So in that case we will have gain of 101. Understood? So this way we can get the output voltage at 2.02 volt. Understood? So this is how we are going to vary the feedback resistors as, let's say, 1 mega ohm. So to write 1 mega ohm, 1 m is not enough. We have to write m is z. And then this will be, let's say, 10 kilo ohm. And what else is remaining? We have the output resistor. Let's say 10 kilo ohm will keep. Don't keep very less value, otherwise it will start loading. So I just want to make sure that it works properly. So 0.1 microfarad will keep, okay? Alright, so all the values of resistors, capacitors, voltage, and properly designed op amp, everything is done. Now what we can do is we can directly run it, or you can go for configure analysis, right? So since it is first time, you can directly run it, no problem. And it will ask you to find the stop time. So since my a piecewise linear function, which is the current source, is up to 2 seconds, why don't we run it to, let's say, 3 seconds? So it will be nice, right? And start saving data from 0 onwards, okay? So my my circuit is ready and my transient response is also made properly. So you can see we have the output window. Now what we can do, we can see what is the current that is flowing to the input. So you can see very nicely from 0 milliampere to 20 milliampere it is reaching at 1 second. Understood? And similar to that, from 20 milliampere to 0 milliampere it is reaching at 2 seconds. So my input is fine. Now coming back to what is the voltage that is generated at this particular non-inverting terminal. So if you click at this node, you will see the voltage is 20 millivolt, right? 20 millivolt. Current has shifted to right side and voltage is there at left side. So 20 millivolt. But you are not able to recognize the node. It is telling VN004. Similar to that, if you go output, it will give you 2 volt, which is VN003. So to recognize the node, what we can do is we can name the nodes, right? So to name the node, we can press N for naming, and then write it V in. So I'll put it this one node as V in, this one I'll put it as VA, and this one I'll put it as V out. Okay. So right click this name and make it V out, and then right click this name and make it VA. If you want, you can put this also. Let's say I'll put it VO. So this node and this node will be showing you same voltage level. That's not a problem. Now you rerun it. Okay. So you can see my current is 20 milliampere. The input voltage Vin is 20 millivolt, and the VA will be actually following the voltage at non-inverting node. So you can see voltage at VA node is also 20 millivolt. Now it has been amplified to 101 times. It means it will give you around 2 volt, right? So coming back to output voltage at this point also will give you 2 volt. You can see this is my V of VO. So that is your 2 volt, 2.202 volt, right? Or otherwise this volt is also 2 volt, right? Now we can do one thing. Right click here and add a plot pane. Okay, so in that case what we can do is we can see this is the input voltage V in and this is the output voltage, purple color you can see. We'll put 1 let's say this is my input voltage down 20 millivolt and this is my output voltage up, which is 2 millivolt. Understood? You can see we have 20 milliamperes of current through this source and 20 millivolt of voltage at this particular input, and the output voltage is 2. Now if you want, you can like vary this particular resistor. Let us say 0.887. Okay, so it will give you exactly, I think, 2 volt. In that case, if you rerun it, it will give you, yeah, see, it is giving you 1.8 volt, right? So based on the voltage that is developed here, it will get amplified, and the whole range that will be there is from 0 to that 1.8 volt or 2 volt or whatever the range that you want at the output, that you can get very easily. Okay. Alright guys, so hope you have a now very good understanding of like how to design your circuit, or how you can convert from current source to voltage source using an op-amp. Based on your requirement or your understanding, you can choose a particular op-amp that you need for any design. So if you do have any questions regarding the current to voltage converter, or how we should start, what are the principles of making the circuit, and how we can basically design our current source to a voltage source, you can refer this particular circuit design, and you can fulfill your design requirement. Thank you so much.